Hello testers and welcome to another STP community webinar. My name is James, I'm event coordinator here at STP. We are excited to have everyone on the webinar today. Today we are joined by Steve Hilton from MachNation. He's joining us from Harrisburg, North Carolina, and he'll be talking about why enterprises are conducting performance testing for their IoT and give the top 5 performance tests they are organizing for their Internet of Things. A few things to go over before we get started today. A reminder, we have an upcoming webinar on March 10th from Brendan Connolly, and the presentation is on extending test automation with Jupyter Notebooks. Visit SoftwareTestPro.com to read more about and register for the webinar. You can also view all the upcoming webinars from STP that are scheduled so far in 2021. Looking to practice your speaking and presentation skills or have an idea for a webinar topic? STP is looking for both new and veteran speakers and is currently filling the 2021 community webinar schedule. So submit your proposal today at SoftwareTestPro.com. If you're on social media and talking about today's webinar, be sure to tag us at SoftwareTestPro and use the hashtag STPWebinar. Also give Steve and MachNation a follow while you're at it, at Steve Hilton and at MachNation IoT. And with that, please welcome Steve. We're excited to have you today on our webinar. And let me give you control.
Thanks, James. Can you, yeah, everyone can hear me?
We can hear you.
Good deal. Well, it's my pleasure to be here today. Thanks for inviting me. I'm going to be talking today about the top 5 performance tests for the Internet of Things. And this presentation is sponsored by MachNation MightyPF. That's MachNation's end-to-end IoT performance testing software. Special thanks to software test professionals for having us here today. Just by way of introduction.
Hey, Steve?
Yes, sir.
Real quick, we don't see your slides yet.
Okay, that's a problem. Let's see, how do I get these up? How about this? Can you see them now?
There we are. Yep, all set.
Okay, good deal. Thanks for letting me know.
Mm-hmm.
Okay. So just by way of introduction, MachNation is a software and services firm. We specialized in testing and benchmarking IoT platforms and end-to-end solutions. We're based in Boston in the United States, and we are in our 7th year of business. We do 2 primary things at MachNation. We run an IoT test lab, and that test lab, we call it Mighty, M-I-T-E. And there are really 2 things we do. The first is what we're really going to be talking about today. In our test lab, we have IoT performance testing software and services and it's a product that we've built called MightyPF. So we actually use that product to do this IoT performance testing. And so what we're going to be talking about today is a lot of the sort of insights from using that product. The second thing we do in our test lab is we use IoT platforms and end-to-end solutions and technology itself to understand at a very deep level the capabilities and the UX of these pieces of technology. We have found in the Internet of Things that all the vendors talk about what they can do and how great their products are, but really the only way to know what the technology can and cannot do is to use it yourself. And that's exactly what we do in Mighty, in our test lab. We use this technology to understand the capabilities and the UX. Also, by way of introduction, so my name is Steve. I'm the president of MachNation. I've been in the tech sector for about 25 years. Half of that time I've worked at large and small, mostly software companies, either in technology or also in the telecommunications industry. And for the other half of the time, I've sort of worked in consulting, and I've been an industry analyst for a bit as well. Okay, so if you want more information about IoT performance testing, on all these slides, there's going to be some contact information at the top. You can email us at info@machnation.com, or you can hit us up on our website, machnation.com/contact. Just so you know, if at any point you have any questions or want follow-up, please do that. Also, we don't necessarily have your contact info. So if you want to make sure that you're on our newsletter and you're getting more stuff from us, more free research about IoT performance testing, hit us up. send us an email at info@machnation.com or on our contact page so we can get you some stuff. And if you want to download this presentation, it's going to be up on the Software Test Professionals website with the audio recording and video recording as well. If you just want the sort of presentation deck, you can go to machnation.com/performance3 and you can grab it there as well. And there's lots of other information about performance testing on our website. So without further ado, let me go through the agenda of what we're going to be talking about today. There are going to be 6 things we're going to be talking about. The first one is Internet of Things 101. I'm going to do like a 30,000 foot view or 10,000 meter view of the Internet of Things, just to make sure for some folks on this webinar who aren't 100% familiar about IoT, we sort of level set. Secondly, I'm going to talk about IoT performance testing. What is it? And why do enterprises even bother doing it? Thirdly, I'm going to talk about why is IoT performance testing not the same thing as website performance testing? What makes it different? And if you're doing some of this IoT performance testing today and it's not going so well, I'm going to tell you why it's not going well. Fourth, I'm going to talk about what are the top 5 performance tests for the Internet of Things. MachNation's customers are a mix of large industrial enterprises, IoT platform vendors, and communication service providers, so like large mobile phone companies, right? All of these companies do performance testing. So I'm going to be talking about the top performance tests that we do with them using MyDPF. Fifth, I'm going to talk about what is needed for best-in-class IoT performance testing software. And then I have a little information if you want to learn more about enterprise IoT performance testing. So that's the agenda for today. Let's go into it. Internet 101, what is the Internet of Things? Well, if we use the source of all definitions, Wikipedia, the Internet of Things describes a network of physical objects, things, that are embedded with sensors, software, and other technology for the purpose of connecting and exchanging data with other devices and systems over the internet, right? So it's this connecting of all kinds of physical objects that are generally not people. So we're connected with our smartphones, right? The Internet of Things is the connecting of everything that is not the people, people in the world. It does include animals, though. There are plenty of connected animal solutions like connected cows, connected horses, connected sheep. That's very big, actually, in the agricultural and animal husbandry sectors. If we look at the technology of what the Internet of Things is made of, I've really simplified it here, but basically at the bottom, we've got devices and sensors. Now, there may be a couple layers of these, right? So you may have sensors that are dangling off of an IoT gateway, right? So there may be a couple layers of devices and sensors, but you've got this set of hardware, right? And that's streaming data over some connectivity protocol into what we call an IoT platform. That platform generally does 2 things. It generally manages the devices themselves, right? So that you can do firmware and software updates and security updates on the devices themselves. And it also manages the data, right? The data flowing into it, right? So that IoT platform handles data coming in from it southbound, and it then figures out what to do with the data sending it northbound, right? And at the top of the stack, we have these things, we call them applications. They can be pretty diverse, right? So it could literally be a mobile app on someone's phone, right? So they can check the status of, the lighting in their house, right? It could also be an analytics application that's doing some very, very complex machine learning algorithms, for example. Those would both be examples of applications that reside northbound, right? And take data from the IoT device and data management platform. But that's the generalized, simplified IoT technology stack. So a typical IoT use case, imagine a connected heating, ventilation, and air conditioning system, right? An HVAC system. That thing would be fitted with some kind of sensors. Maybe it feeds into a gateway. That device, the data that's coming off then of those sensors and off of the connected HVAC stream into the IoT platform, right? And then those are shared northbound. They can be queried by, say, a mobile IoT app, right? Queried out of the platform, or maybe they're fed northbound into an analytics tool. So that would be a typical IoT use case example. So I hope that explains what we're talking about today with Internet of Things. Now, let's talk about IoT performance testing. What is it and why do it? Okay, so let's go back to that technology stack, talk about what is IoT performance testing. So IoT performance testing is sort of represented by these two sort of bracketed arrows on this technology stack. Let me take the one on the right first. Okay, so performance testing actually tests the data and the workflows that are going between the devices and sensors over the connectivity protocol into the IoT platform, right? And interestingly enough, in IoT, it's not data going and workflows in one direction, right? Data can go in two directions. It can go from platform to device. It can also go from device to platform. So we're testing the performance of that data and the various workflows that happen between device and platform. That's the first bit of IoT performance testing. The second part of IoT performance testing takes place between the application layer and the IoT platform, right? So as I mentioned before, the applications can query the IoT platform to get data from it, to get device status, to get all kinds of information, right? So once again, a mobile app can query the platform. Analytics applications can query the platform. Also, so you can build small dashboards or little visualizations that can query a platform, right? So once again, there's data and workflows that go in both directions, bidirectionally, between the application layer and the platform. So that's really what we're doing in performance testing. Those two things, testing from the platform northbound to the application and from the platform southbound into the device. Why do enterprises do IoT performance testing? It's really pretty straightforward. Enterprises need to be able to offer extremely resilient, reliable, performant IoT services to their customers. They want to be able to prevent unplanned IoT system problems. These enterprises, the IoT sort of unit of an enterprise often sits inside a digital business unit, has very tight relationships both to the IT organization, right, to the CTO's organization, but also very tight relationships into what's often called the OT, or the operations technology side of the business. So that's often the sort of the product units at these industrials. So think of an industrial like Bosch, right? So you've got sort of a digital business unit or a software unit, right, that offers IoT services to all the product divisions at Bosch, right? So the product divisions may be making, things that go inside connected cars, right? Or they may be making power tools, right? Those business units use the IoT technology that Bosch has, this technology stack, right? And so it's in Bosch Software's best interest, or it's actually called Bosch.io. That team's best interest to prevent all sorts of unplanned IoT system problems. The other reasons enterprises do performance testing is they want to be able to offer credible and profitable SLAs, service level agreements, to their customers, right? So the industrial wants to make sure that they can offer a high level of SLA to one of the business units or to their end customers associated with the connected air conditioner that they're selling, right? They want it to be a credible SLA, but they also want it to be profitable so that they know, if we're going to offer, 2 nines of reliability, for this connected solution, they want to make sure that they can actually offer it and they're not going to be, violating the terms of the SLA and therefore owing money back to a customer. Fourthly, enterprises are doing IoT performance testing to make sure that they don't over or underspend on their infrastructure as a service or platform as a service stack, right, to manage their IoT software. If you think about their IoT software, this IoT device and data management platform has to reside on infrastructure somewhere, right? And so they want to make sure that that the performance that's generated by that platform is properly understood so that they can scale their solution properly and don't overspend or underspend on their infrastructure. And finally, they do performance testing of IoT because they want to beat their competition. They want the bragging rights. They want to be able to say, we can offer a higher SLA, we can offer a better product than our customers, than our competition can offer. So that's what IoT performance testing is. That's what it is. That's why enterprises do it. Let me describe to you a little bit about why IoT performance testing is not website testing. I think that the biggest issue here is that companies that fail to recognize this fact that IoT performance testing is not the same thing as website performance testing, it causes those enterprises to do two things. One, they select really poor test tooling. They select the wrong tools to do this kind of performance testing in IoT. And secondly, they waste a huge amount of money because they've selected this wrong tools, and they can't figure out how to scale them properly. They have too much infrastructure for them. They make a lot of mistakes. It wastes a lot of time and money. Why is IoT performance testing not like website testing? I think it falls into several categories. If you think about sort of the device type, so in traditional website or even just traditional mobile app testing, right? So not IoT, just the traditional world, you got a human like me, right? And a screen with an OS. I'm sitting in front of, my little laptop right now, right, running Windows, right? That's typically what we do in traditional website testing. We simulate a bunch of humans with a screen with an OS, right, hitting a website. In IoT, we have to simulate all different kinds of assets. They're not humans, right? They're machines. They might have an OS on that machine, or they might not, right? Because in IoT, you don't have to have an OS. And the number of assets are extremely diverse, from the connected air conditioning system to a parking meter, to a connected cow, a little sensor on a connected cow, right? Or a huge IoT gateway sitting on an oil rig somewhere in the middle of the Pacific Ocean. Right? Those are all assets that we performance test and have to simulate. Device counts. In the traditional website or mobile app testing world, in the traditional world, we maybe simulate hundreds to thousands, maybe tens of thousands of these devices hitting a website, right? In the IoT world, we usually start at tens of thousands of devices and we have to simulate to millions of devices. It's a completely different scale of performance testing. Thirdly, the device load, right? So in the traditional website world, we're talking about sort of a human, we simulate a human with, megabytes or gigabytes per device, per human, right? Hitting a website or using a mobile app. In the IoT world, it's usually kilobytes, very, very small amounts of device load per device. And interesting also is the behavior of those devices. So in a website, traditional website testing, we simulate people who are interactive, engaged with the website, doing things, right? In the IoT world, an IoT device is almost dormant all the time. It doesn't do anything. It sits there and does nothing. And then maybe every 10 minutes it does something, or every hour or once a day it does something and sends a few kilobytes of data, and then it turns off again. Right? So it's a completely different sort of use, behavior of a device. In security, with website or mobile app testing, we're usually doing stuff over HTTPS with TLS. In the IoT world, we actually have to simulate sort of IoT devices with public-private keys, with X509 certs, and also with HTTPS, right? So there's sort of an added layer of complexity with security and IoT. And also typical workflows in the website world, what are we doing? Well, we're really simulating sort of download data, upload data, download data, upload data. That's what's sort of going on in traditional website performance testing. Whereas in IoT performance testing, we've got this bidirectional transfer of data, right, happening from device to platform. We've got queries happening from application to platform. We also simulate FOTA and SOTA updates. So FOTA, that's firmware over the air, SOTA, software over the air updates, right? So the platform telling the device, we're now going to be updating your firmware. We're now going to be updating your software. We have to simulate that in IoT. We also simulate things like event processing and analytics workflows, device management workflows. We simulate all those different kinds of workflows in IoT, things that don't really happen in traditional website performance testing. So once again, IoT performance testing is not the same as website performance testing, and failure to recognize this fact causes enterprises to make some really bad decisions in selecting test tooling. So maybe you've done some IoT performance testing today, and you're wondering, and a lot of IoT performance testing is done with an open source product called JMeter. And maybe you're wondering, and for IoT performance testing, why does JMeter keep disappointing me? And if so, it really comes down to a series of things that we've talked about some of it already. So like with JMeter, you can't test the full device life cycle. You can't simulate photo and SOTA updates in JMeter. You can't simulate event processing workflows, really typical things in IoT that you'd want to be able to do. You can't do that in JMeter. You also, in JMeter, you cannot simulate extremely lifelike IoT devices. JMeter is really good for simulating in the world and performance testing in the world of traditional websites. It does a really good job there because it does a good job of simulating sort of that human, that's what it was built for. But it does not simulate lifelike IoT devices at all, devices that sort of are off all the time and then turn on and send a little bit of data and turn off again like that. It doesn't do very well there. It's also really hard to simulate bi-directional platform initiated actions like a photo in JMeter. So JMeter is really good at sort of sending data from an asset or a device or a simulated thing like a person, to a server, right? But there's not an easy way to cause JMeter to have the action actually start right at the IoT platform and go to the device and then back to the platform and back to the device and back and forth like that, which is a very traditional thing when you simulate a photo. Also in JMeter, it's very hard to scale vertically and horizontally. I don't have the time to describe to you today why it's really hard to do vertical scaling, which means adding more and more and more devices to a single instance of JMeter. Horizontal scaling means that you add more JMeter instances to a cluster. I don't have time to describe that today, but actually in the next few weeks, we're going to have a piece of research on our website, a very technical piece of research about why it's hard to scale vertically and horizontally in JMeter. So, shoot me an email at info@machnation.com and we can get you that piece of research. Also, there's no good way to automate the mass provisioning of device IDs and X509 certificates in JMeter, which is, this is very common in IoT. Devices have individual device IDs and they have X509 certs, but trying to automate the provisioning process of 2 million IoT devices in JMeter is virtually impossible. Also, it's very, very hard to track every single simulated message and event with a unique UUID in JMeter, right? Which is what you want to do in IoT. You want to be able to track every single back and forth of a message, right? And every single device you want to be able to track, simulated device you want to be able to track individually. So if you're having issues with JMeter, one of these 6 reasons, or maybe all of them, is why. So let's talk about the top 5 performance tests for IoT. We've set up now sort of what IoT is, why enterprises do it, where we do the testing, why you might be having some challenges today. What are the 5 performance tests for the Internet of Things? These are the tests that we regularly test for these large industrial enterprises. There's 5 of them. Message ingest, so that's data going from device up to platform. Digital twin updates, I'll describe that in just a little bit. We're going to simulate a query to simulate a mobile IoT app querying into the IoT platform. We simulate a mass disconnect and reconnect event. That's the idea that a bunch of IoT devices, like all of a sudden, disconnect from the platform. They disappear, and then they turn back on and reconnect. What does that mean? We also simulate mass photo and SOTA updates. So these are a subset of the tests that we're capable of performing in MightyPF, but we wanted to give you a heads up. These are the top 5 today. So let's go into them. So message ingest. So what's going on here? So the description of the test, data is going from the device to the IoT platform, usually over MQTT, but it can also, or HTTPS, both are common. Sometimes it can go over lightweight M2M as well. That's a newer protocol that's used in IoT. Why is this sort of test important? Well, it's important to know the efficiency of this very most common IoT workflow, right? So once again, if you think about sort of that middle screen there, the basic test design devices, sending data, right, up to an IoT platform. So back in our air conditioning connected HVAC system example, maybe there's a sensor on the HVAC that measures the outside temperature or measures the RPM, the revolutions per minute of the air conditioning. So maybe that data is being collected on sensors, on 2 or 3 sensors, and then it's, every hour or whatever, it's sent back to the IoT platform, right, to be stored there and analyzed and whatnot. Okay, so that's what's going on. Also, what's interesting to note is when we do this type of performance testing, there are varying device types, rates and frequencies that data is being sent, and loads of these devices. So if we think back to our connected HVAC, maybe the temperature data has to be sent once a day. Maybe the RPMs, revolutions per minute of the engine, is going to be sent once every 5 minutes. Maybe some other characteristic of the engine, maybe there's a fault, setting, right? So that if something goes wrong, if an alarm needs to be sent, the alarm would be sent instantly, but only when it happens, right? When there's an alarm condition, right? So, and maybe for each one of those metrics that's being sent, the load is different. Maybe for the temperature, it's 4 kilobits, and for the revolutions per minute, it's 2 kilobits or whatever, right? We have to be able to model this, right, in IoT, because that's the real use case. You have to be able to model different kind of devices sending data at different rates and frequencies and different loads back into the IoT platform, right? And you have to be able to simulate these various message types. So you may have data that's flowing. I mean, some of these IoT solutions, like a connected connected airplane engine, you may have data that's flowing, every 50 milliseconds, or maybe it's a constant stream of data, huge amounts of data, real-time data, right? There also may be alarm data. That data is not streaming all the time. It only is streamed. It's only sent when there's alarm condition. For example, the vibrations of the airplane engine exceed tolerance, right? So there's these different types of message types we have to be able to simulate all simultaneously, right, at the same time into the platform. So when we do that, the test metrics that we get are message failure rates, what percent of the messages failed over the given time of the test. 20-minute test could be 6-hour test, could be 24-hour test, right? What's the message failure rate, right? By type of message, what we would want to look at and do look at, the message failure rate for real-time messages. So this would be the things like engine performance of that airplane engine, right? As well compared to sort of message failure rate for alarms, right? Alarm messages that come in to the IoT platform. We want to look at latency, so how many milliseconds on average does it take for a message to get from a type of message type to get from the device to the platform? And we want to be able to look at the average latency and the standard deviation and the maximum. We want to look at the 90th, 95th, and 99th percentile of latencies. And we also want to look at disconnects. So keep in mind during the test, 20 minutes, 2 hours, 24-hour test, some of these devices may strangely disconnect, and we don't know why, but they will literally disconnect from the platform, so they will not be there, and then maybe they'll pop back on. We want to be able to collect the data for disconnects by time as well. So that's the first kind of performance test, most popular IoT performance test that industrial enterprises have us run. Second most, or the number 2 popular test is digital twin updates. So let's see. So we have the physical devices that we're simulating, right? Or in an IoT solution, you have a device, right? That device has a representation of itself that's called a digital twin. A digital twin is a digital representation of an actual IoT device, and that digital representation is stored inside the IoT platform, okay? Right, so what's going on is, in this kind of test, we're testing the rate of the platform's capability to be able to accept these digital twin updates, right? So the IoT devices are updating their digital twins over HTTPS into the platform, right? And we want to be able to capture how fast over HTTPS the platform can accept these updates. It's important to know this information. It's important to know that the device updates its digital twin because the IoT application, right, at the very northbound layer of the stack, relies on the digital twin for its data, not the actual device, right? So when we said earlier that an IoT application will query the platform to find out, what's going on with these devices or get alerts or whatever, it's not, you don't query the actual devices. It just queries the digital twin inside the platform. So it's really, really important to know the status and sort of the capabilities, the performance metrics of a digital twin. And so once again, when we do this kind of test, we have to be able to simulate varying device types, as we described earlier, with different rates and frequencies of messages in real time, sort of not in real time, and sort of alarms, right, going into the digital twin. We have to be able to simulate different loads by device type as well. And we have to be able to simulate different types of message types. And we have to be able to do all of those types of devices and message types simultaneously. And we have to be able to, once again, get performance metrics for each device type, for each message type, right, to understand the performance characteristics. What are the interesting sort of test metrics that we generate? Well, things like get and post failure rates by time. So once again, understanding the get and post failure rates of those messages going into the digital twin. We once again want to understand latency. How long does it take in milliseconds to send in those messages on average? We also want to understand disconnect. So once again, if devices disconnect, we want to understand the characteristics of the disconnect and when they happened along sort of the length of the test. So the digital twin update is the number 2 IoT performance test that we complete for enterprises. Let's go on to number 3. So number 3, we've talked about this a little bit, is the ability to run queries to simulate a mobile IoT app or to simulate an analytics application querying the IoT platform, right? So this is something northbound to the IoT platform querying it. So this kind of activity, once again, this is the application querying the digital twin inside the platform, and it's usually done over HTTPS, right? So we have to be able to create that simulation. This is important. We do this kind of simulation because it's important to know how the IoT app performs, right? And if you think about it, in everything in IoT, we haven't even talked about people yet, but it's the IoT app that sort of a person most often interfaces with that IoT app, right? Or a visualization tool, the northbound part of the platform, north side of the platform, right? And so it's really important to know how that app performs, right? And how the platform is interfacing with the app, right? Because that gives us really good insight into sort of the user experience of the application, right? So if a user gets on his or her smartphone in a factory, a factory worker, and needs to pull up a quick dashboard to look at a series of robotics equipment in the factory, and presses the button to run that query, and it takes 10 seconds to pull up that data, it's a terrible user experience, right? So we want to minimize that, and we do that through, once again, performance testing and simulating a query from the northbound app to the IoT platform. And once again, we have to vary these query types, right? So there are real-time queries, there can be simulated trend type queries, there can be alarm style queries, all kinds of queries. There can be analytics workflows that we can simulate back and forth between an analytics app, right, and IoT platform, all kinds of different workflows, right? They'll have different rates and frequencies of data going back and forth, different loads of data. Also, And once again, so these types of queries, you have to be able to simulate them all simultaneously, once again, right? Because there's different kinds of queries happening. It's not like just one kind of query. It happens all the time with a given IoT solution. Extra credit testing, and this is what we do for our customers who are interested in it. It's really important to validate that the most recent device state is the data that's queried out of the digital twin, right? So if you think about the digital twin, which is once again a digital representation of the device, it's really important to know that if you're on the shop floor and you're running a query on your tablet or phone to understand what's going on with your equipment, it's really important to know that the data that's in the digital twin is actually the most recent device data that was sent into the digital twin, right? And so what we do with MyEPF is we actually correlate the test results from the query test and from the digital twin update test to make sure that the data that is queried out is actually the same data that was sent into the IoT platform. So that's extra credit testing, but it is incredibly important. So if you think about the basic test design, once again, this is a northbound app querying the digital twin southbound of it, right? And the test metrics are pretty similar, right? Once again, we want to understand failure rates of a query. We want to understand the latency, so how many milliseconds on average does it take to perform a query? And by the way, so latency on the query side is almost always quite a bit higher than latency rates on the southbound side, so sort of the data ingest side or even updating a digital twin. So the queries tend to be slower in IoT, sort of the nature of the beast. We also want to know, as I was describing before, this accuracy percentage. So what percentage of the queries of data, queries of the digital twin actually gave us the most recent data that was sent in from the devices into the digital twin. So really interesting test results we can get by queries to simulate a mobile IoT app. Number 4, test IoT performance test. Really cool one, mass disconnect and reconnect event. So what's going on here? This is really a 2-step test. The first thing is, imagine you've got 1 million devices connected to an IoT platform. We simulate a failure, a massive failure, where we disconnect 30 to 50% of them. So 300,000 to 500 devices all of a sudden disconnect and disappear from the platform. Then the simulation waits 5 to 30 minutes, or it could be more. And then instantaneously, we reconnect all those devices, 300,000 or 500,000 devices, instantaneously reconnecting to a platform and sending, their reconnection request, right? The platform has to send an acknowledgement back, right? That yes, you're connected. And then the device, all at the same time, starts streaming the last 5 to 30 minutes of their cached data, right? They're still collecting data from whatever the device is connected to, from the connected air conditioning to the air conditioning. It's still collecting the data. It streams all that connected data back to the platform all at the same time. So we actually do that 2-step test. We simulate that. Now, this is a really interesting example of IoT chaos engineering, right? Because in the IoT world, one of the things you don't want to have happen is 30 to 50% of your devices going offline, right? Completely disconnecting, but it happens. And then when they go back online, they're not like humans. They're not smart enough. They're not interconnected with each other. They don't sort of each take a turn to sort of reconnect. They all reconnect at the same time, right? It's massive load, right? It's a great example of IoT chaos engineering. And by the way, we've got some research coming out on IoT chaos engineering on our website in the next few weeks as well. So once again, hit me up on email or at our contact page at MachNation if you want to get some research about IoT chaos engineering. So it's really important to understand how the IoT system handles this kind of real world disconnect disaster, right? So we describe these 2 sort of basic test designs, right? You've got devices that disconnect from a platform. That's step 1. Step 2, the devices reconnect. They have to acknowledge the platform acknowledges the reconnect, then the devices start streaming their data and updating the digital twin all at the same time. The test metrics from this, the number of reconnect attempts. So sometimes these devices, the 300 to 500,000, don't reconnect on their first attempt because the platform is overwhelmed, right? So, how many reconnect attempts does it take Just take 1, 2, 3, 4, 5, I think this little chart shows, 72.5% of the devices reconnected with one attempt, 28.8% of the devices reconnected with 2 attempts, right? So you want to have that kind of data. We also want to know what percentage of the devices failed to reconnect totally, right? Which also happens. We want to know the time to reconnect, right? So you want to have a sense of, it took, less than 1 second for 25% of the devices to reconnect. It took from 1 to 5 seconds for 13% of the devices to reconnect. It took, 1.1% of the devices took between 5 and 15 seconds to reconnect. In fact, that's really important information. And once again, we want to know latency, right? So latency rates on this data that's flowing in from the message ingest and the digital twin update. Keep in mind, 30 to 50% of the devices disconnected. That means that there were an awful lot of devices that didn't disconnect, right? They were still connected, right? So between 50 and 70% of the devices were still connected, doing their normal thing, sending in messages and updating a digital twin. We have to be able to simulate those 50 to 70% of the devices and the 30 to 50% that disconnect. We have to be able to simulate both things simultaneously and collect IoT performance statistics for all of them, right? So it's a really, really great problem to be able to solve for our customers. The last performance test that we do, number 5, mass FOTA or SOTA updates. So this is also a 2-step test. So basically, in a FOTA or SOTA update, this is firmware over-the-air update, software over-the-air update. What's happening is the platform says to the devices, I'm ready to send you new firmware or new software. We're patching a security patch, right? So that's what the platform says that to all the devices. The devices say, yes, I'm ready to accept that update. And then there's a series of back and forth where the data is delivered down to the device. The device updates, hopefully it's successful, not all the time, and that's part of what we're going to capture with our test metrics. Once the FOTA or SOTA update is completed, the device sends a message and updates the digital twin and says yes with an acknowledgement, an ACK, and says yes, the FOTA or SOTA update was completed. Or it can actually send back a message, an error message into the digital twin saying, no, we got a problem here, right? So note, this kind of test, a FOTA or SOTA update, is IoT platform initiated workflow, right? This is something that you cannot do in JMeter, right? To initiate something on the platform side, it's a really unique thing to be able to do and a unique need in IoT testing. It's also bidirectional and multi-step communication between the device and the platform. There's a series of back and forths from platform to device, from device to platform, and back and forth. In the IoT performance test, you have to simulate that entire workflow. You can't just simulate the platform updating, sending a heavy, load down to the device, simulating just sort of that update, right? That's not what happens in IoT. There is a set of back and forths that happen, and that's for a FOTA or SOTA update, and that's what you have to simulate. And you have to be able to capture these various actions back and forth. You have to be able to capture the acknowledgements and the errors. So what are the test metrics we capture for this kind of update, for this kind of test? We capture a multi-step failure rate. So if a failure happens, where does it happen, right? For each one of the devices that's undergoing the FOTA SOTA update. Is it with the initial sort of platform initiated message down? Is it with the sort of the end step of the device, you sort of acknowledging the FOTA or SOTA update? We also have to be able to capture the phase of failure, sort of where did the failure happen all along, sort of from step to step, whether it's a 4-step process. Sometimes it's a 4-step process, sometimes it's a slightly longer process, but it's, it's in that range. And we have to be able to capture the latency. How long does it take for these back and forths to occur, right? FOTA and SOTA updates are extremely bandwidth intensive in the IoT world. You don't want to do them too often because most IoT networks are not built for sort of heavy FOTA SOTA. Also, you want to be able to sort of stagger SOTA and FOTA when you do these updates, right? So generally in IoT, you don't do sort of, let's say you have 1 million devices, you don't do the FOTA and SOTA updates all at one time because that would absolutely crush your network. So they tend to be staggered. So in the performance testing, you want to do the same thing. You want to run it over a 24-hour period, and you want to stagger, right, your FOTA and SOTA updates according to what you would do in the real world. Okay, so we went through the top 5 IoT performance tests. I just wanted to get, as we get into the end here, just want to conclude with a couple thoughts. Best-in-class IoT performance testing software, once again, you want to be able to simulate extremely realistic simulated IoT devices, right? These simulated IoT devices need to be persistent, right? So they need to be able to do sort of multi-step process, and they need to be able to sort of just stay there and do nothing for long periods of time, right? And then send an alarm message and then do nothing. And then send another alarm message and do nothing, right? So they have to be persistent, they have to be independent. One device should not be impacting the performance of another device, because in the IoT world, these devices are not connected in any way with each other. And there should be a way to be able to simulate these at any scale, from thousands, tens of thousands to millions of these simulated devices, speaking MQTT, HTTPS, WebSocket, and other protocol. We need to be able to do fast, easily repeatable test design, right? So it's very common. The way we do it is we have a template-based design that we do up in JSON, right? So because when we do these tests, maybe first you want to simulate 10,000 connected devices of different types doing different kinds of things. The very next test you're going to want to do is 50,000 devices, right? It should all be template-based. That should be a very easy switch to make. You know, it takes 5 minutes to switch on your template, to change in your JSON template, right? And run the new test. Thirdly, we want to be able to have coverage for all real-world IoT message flows. Once again, IoT workflows, not the same as web traffic. We want to make sure that we are able to simulate these complex IoT workflows with logic built into the workflow. Also, we believe best-in-class IoT performance testing should be sort of pay as you go, right? You should pay for testing only when you're doing testing, right? So the way we do that is we make sure that our tool, MyDPF, it's 100% serverless. It's infrastructure as code. It's API-driven architecture, right? So we personally only pay for testing when we're using MyDPF. That means our customers are not having to take a JMeter instance and put it on a big piece of infrastructure, and you're sort of paying for testing, even if you're not doing testing. That doesn't make any sense to us. Fifthly, you need to be able to have extremely refined output metrics for every action. Every message that's sent, every device you simulate, right? Every back and forth within sort of a workflow needs to have a unique UUID, right? That is not possible in legacy testing tools. The metrics that you can get are very high level, but what you really want, a DevOps department, engineering department at these industrial enterprises want a way to really dig deeply into failures, into problems with their platform. The only way to do that is to have really extremely refined output. And finally, you want to have complete auto scalability. You want the ability for the design of your testing tool to completely scale up and down without any thinking on the part of the testers or on the part of the industrial enterprise that you're working for, right? And the way that we do that is we rely on best-in-class hyperscale cloud tooling that requires no management of the infrastructure for your test tooling, right? And that takes all kinds of pain out of IoT performance testing. So, top 5 performance tests for the IoT that we went over today: message ingest, digital twin updates, queries to simulate mobile IoT apps, mass disconnect and reconnect events, and mass FOTA or SOTA updates. Oh, okay, so my team put a sixth one on here. The sixth one that we love to do, we call it the bonus test, is a simulated DDoS attack on an IoT platform. So everyone knows that IoT, there have been some pretty sort of high profile sort of security issues in IoT. So DDoS attack is something that we simulate for our customers, right? That helps them test their sort of security systems in their IoT platforms. How does their platform gracefully recover from a simulated DDoS? So that would be a 6th performance test. If you want more on that one, once again, contact me at the places above. Okay, so we've reached the end of the formal presentation today. I appreciate you spending some time with me. If you want some more information about IoT performance testing best practices, some issues around JMeter and some legacy website testing tools, or some more information about IoT benchmarking and testing, feel free to get in touch with me. I really appreciate the time today, and I really appreciate software test professionals for having me on today. Thanks again. And
Awesome.
I think, James, maybe a little bit of time for questions, a couple questions.
Yeah, we do have some time for questions. Let's see. Let's get to one. Are businesses doing performance testing with their existing QA and testing teams, or is it being done with a separate IoT team?
Oh, okay, so good question. So most of these enterprises I described before, they have a separate sort of digital business unit or a software unit that's built these sort of IoT platforms, these tools, the platforms themselves, right, that they're going to use for their customers. So in those teams, there's usually some specialists who are IoT specialists who do the testing today. However, more and more what we're seeing, and when we engage with our customers, a lot of the time that we spend is with those few people that are doing the performance testing for IoT. They actually bring in their peers from sort of the legacy side of their business, the sort of website testing or the app side of the business who do testing. And a lot of the time we spend is actually sort of educating that broader team on the unique nature of how you do IoT performance testing, right? So I think more and more those fuller teams will be getting good at IoT performance testing. They're just probably not there today.
Got it. Perfect answer. Next question. This one's a bit long and looks like there's two parts to it, so bear with me here. Hi, thanks for the presentation. Two questions, please. One, do you also design custom test suites in MIT EPF for your clients, or do you just provide the MIT EPF platform for clients to design their own test suites? And number two, once you've designed a test suite, provided you do, can a company re-execute it on its own? In other words, MIT EPF discovers a performance issue. We try to fix it. How can we rerun the test to see if we really fixed it or not?
Oh, two really great questions. I'll take them in order. So almost all the time we work with our customers to model their specific IoT implementation, right? So we're modeling their stack, sort of the device types that are streaming into the platform, the queries from the application, because every IoT use case is different. So we work with them to model that, and we model it in one of our MightyPF templates, right? Which is basically a JSON template, right? And then we can run that test sort of over and over again with our clients, right? And if they want to change things, it's very easy, right? Because everything's been specified in the JSON template. You want to change the number of devices, you want to change the query rates, you want to change the ingest rates, right? You want to change sort of the steps in the PhotoSoda update process. Just change, the steps in the JSON. It's really quite easy. And often you could call it like a managed service. We do that to help our customers because oftentimes they sort of need that added support. So we'll work with their engineering and DevOps teams and their testing teams to make all of this happen and design this up in MightyPF. It is also very common that we run the test once and we discover problems on our customer's IoT solution in their IoT platform. Their DevOps team and engineering teams figure out with us, with our engineers, we work together, we figure out what the problem probably is, they go and fix it, we press the button, we run it again. I mean, it's a template once again. So once it's designed and the template, sort of the parts of the template are in place, to rerun it is just like you just press the button, right? So it's really, really quite easy. I hope I answered those two questions.
Yeah, I think you did a great job. That was a great answer. The next question, is anyone using lightweight M2M as a connectivity protocol in the IoT today, or is it just mostly MQTT?
Yeah, okay, well, so good question. So maybe that's a two-part question, actually. So most customers are not using lightweight M2M yet. That's a new protocol. It's got some real benefits, but it is pretty new. It's often used for very constrained devices, so very lightweight devices that sort of maybe just run on battery power, as opposed to devices that have access to an AC source, like heavyweight devices that have access to power. So most customers are doing MQTT. Still don't use lightweight M2M that much. That said, we've had requests to do lightweight M2M testing in MightyPF, and it's a very unique process, very interesting as well. So if anyone wants to talk more about lightweight M2M, just hit me up. I'd be happy to talk about it.
Awesome. And looks like one last question. What other chaos engineering are businesses doing in IoT?
Ooh, so chaos engineering IoT is like a really new area. So those who know about it, so chaos engineering means that you create some kind of drama, right? There's some kind of fault, right? A catastrophe sometimes, right? That happens in your system somewhere. It could be the infrastructure, it could be the application layer, it could be in the platform, it could be anything, right? Something goes wrong. What happens? Also, chaos testing is often done in these systems in a production environment. So that doesn't happen too often in IoT. Most chaos engineering is done in a pre-production environment or even in a test environment. So, so one chaos test I described today, right, which is mass disconnect. 30% of your devices all disconnect at once, and then they all reconnect at the same time. That's a really common chaos engineering test. And then what happens? Another one would be, actually, I mean, a security style chaos test, a DDoS is a really good example. I mean, that just puts massive load on a platform. Then what happens, right? Like that's a good example of chaos testing. Also, if you could think of another chaos engineering IoT might be applications northbound of the platform go awry and start querying at rates that are completely outside the normal range, to simulate some kind of sort of malware sort of northbound into the platform. So that would be another good style of chaos engineering. There are other ones as well. So if you want more info, just let me know. We've got some research coming out on it.
Great. Thank you, Steve. That was a great presentation, great deep dive into performance testing for IoT, and we enjoyed having you today. We look forward to having you hopefully soon at a in-person conference next time.
Oh, I'd love that, James. Thanks so much for having me today.
Great, thank you. And just before we go today, just a few announcements. Our next scheduled webinar will take place on March 10th. Brendan Connerly will be giving a presentation on extending test automation with Jupyter Notebooks. Visit SoftwareTestPro.com to sign up for this webinar and also sign up for any other upcoming webinars from SDP. If you'd like to be considered for a webinar presentation or have an idea for a great testing topic, please visit SoftwareTestPro.com to submit your proposal. And with that, thank you, Steve. We enjoyed having you. And thank you to everyone who attended the webinar today. Have a great day and stay safe.